Hello everybody. Today I'm going to be doing some Diffie, just a simple separable one. I mean, it's kind of hard, but we'll see. I haven't done it yet, so I'm just going to jump right in. So, this is a separable equation. We want to try matching up the differential with the variable, right? So you can see right now it's a little mismatched. We have the y terms with dx and the x terms with the dy. So we want to get, we want to multiply by something that's gonna wipe out, uh, you know, both sides and get them all back on track so we can integrate. And the way I'm looking at it now, it seems like the whole thing is just cooked. You see that the y's are all with the x's, and all of the x's are with the dy. So we're just gonna throw everything into the denominator and multiply across. To save some time, I'm gonna copy paste this. Hope you don't mind. So we're trying to get this in the denominator, right? And then we multiply that to the entire equation. So yeah, the whole thing, I'm gonna multiply it to. And I know this seems kind of crazy, but I just want you to focus on the fact that this is gonna move. It's gonna, first of all, it's gonna get this out of the way when we. Well, let me just show you. You know what? Show, don't tell. We're gonna have this whole term times this term, and then just a little part of the x there. And then we're gonna have, again, this whole term plus. Let me put little brackets in here so it's not too confusing. This whole term plus this whole term. Okay. And, well, what's going to happen here, this e to the negative y is going to go away here. This whole thing is going to go away here. And what's left over with this term, look at that. You have the x's and the dx. So let's put it just like that. Dx plus 1 cubed. Let's put this e to the negative x up top, just because. Dx. Okay. And then here, it's the same story. It's kind of clipping out here, but these two go away here and here, and you just end up getting something pretty easy to work with. So you get plus e to the y over e to the y plus 1 squared dy equals 0, of course. This whole thing times 0 is just 0. I kind of set this up in a weird way. I'm gonna move this whole thing over. Bear with me, please. Okay. So what now? Now we have terms in x with a dx and a y with the dy. It's kind of just... It's time to take an integral. We just put the integral sign on both sides to the whole equation. Because it's a linear operator, we can just do that. Dx plus integral e to the y dy plus 1 squared dy equals integral of 0 is just 0. Okay, so how do we integrate these? It's giving me a... Well, what I think we can do is... Well, I would try doing a u sub, but if we... Let's just say we do u is equal to e to the x. It's not going to work. Okay, you're going to get e to the x dx Or maybe it will work, actually. Yeah, this works. Okay. Again, I haven't really solved these. I'm just kind of going through it. So, okay. It's pretty cool. So u is equal to e to the x. Du is going to equal to e to the x dx. So we can rewrite this integral as 1 over u plus 1 cubed du. Okay. And let's just work on one at a time. It's going to be a very similar result, so nothing really lost by taking our time here. So now we got to integrate this. Well, okay, wait. Let me tweak our thing really quick. We're gonna do e to the x plus 1, because what I was about to do was do like another sub, like w is equal to u plus 1, then, you know, dw is equal to du. But you can just kind of mesh these together. If you do u is equal to e to the x plus 1, then the one's going to go away when you take that derivative. So derivative of e to the x is just e to the x dx. Derivative of 1 with respect to x is just nothing. So e to the x dx. So we can rewrite this whole thing as 1 over u cubed. And this is very easy to integrate. We just gotta add 1 and divide by whatever this. So if we add, well, let's not get lost here. We have u to the negative 3 du. We're gonna add 1 and then divide. So negative 1 half integral u negative 2. Sorry, no longer integral. Negative 2 du. Sorry. Yeah. And then we're gonna substitute in our u, which was x e to the x plus 1 to the negative 2 power. Okay. And then if we use that same reasoning, we can easily see that we're just going to be adding 1 over... Let's use the same notation. We're allowed to do that. You know, you can dot dot dot, whatever. It's going to be getting negative 1 half e to the y plus 1 to the negative 2 power. Oh, wait a minute. Little mistake. Not quite. Not quite, my bad. Because it's not the same power. This is 2 and this is 3. So we're gonna have to rewrite it. Let's just do the integral. U is equal to e to the y plus 1. Du is equal to the y dy. And when we put it all in, we're gonna get integral of 1 over u squared du. And then, you know, we divide. We're going to get negative u to the negative 1. Negative 1 over e to the y plus 1. So at the end of the day, it's negative 1 over e to the y plus 1. Equals what now? Well, we just did some integrals. I kind of missed the part where they spit out constants. So you're gonna have like a plus c to your answer, right when you get about here. Plus c. Here too, a plus c. Well, we can just kind of combine the c's together and move them to the other side. So we're gonna have the whole thing equal to c. And we can just rewrite as 1 half. Well, let me keep this property. So 1 over 2 tx plus 1 squared minus 1 over e to the y plus 1 equals c. And let me check if that's the right answer. If not, we're going to have to go back. But if you watch this far, then I know that I've got you. Alright, so one quick thing they did was multiply everything by -2. Just to clear out the negative, make it look a little more nicer. Get rid of that 2 down there. Um, and they rewrote it like this. So when you distribute the 2, you're gonna get e to the x plus 1 to the -2 plus 2 e to the y plus 1 to the -1 equals c. -2 times c, that's still a constant, so that's your final answer.